Today's lesson is about similar solids. Yay! When we say that two things are similar, we're not saying that they're equal, but instead they're like, meh, kind of alike. Luckily, there's a way for us to describe their likeness with what we call ratios. This guy. Yay, middle school math. Let's take a look at these two rectangles. They obviously aren't congruent, but they are instead similar. Allow me to give these bad boys some measurements. I'll say this one's 2 and 4, 3, 6. Alright. Now, since they're clearly not equal nor congruent rectangles, we can describe their similarity with a ratio. Making ratios with corresponding side lengths, we can see that there is a relationship. So let's see. I'll say 4 corresponds with 6. 4 over 6, which reduces to 2/3. I'll take the next two sides, 2 over 3, and I get also 2/3. Now you can see that the ratios are the same, meaning that these two figures have to be similar. Yay! So we just took a look at the side lengths and showed that if two shapes are similar, then the corresponding sides share a common ratio or scale factor, A over B. This also happens to be true with the area and volumes of similar figures. For the area of similar figures, area, we'll say the ratio must be A squared over B squared. For volume, the ratio must be A cubed over B cubed. So let's look back at our rectangles. Remember, our scale factor for these was 2 over 3. We had 2 here, 4 there, 3 there, 6 there. Now for area, remember it's length times width. So what do we get for this one? We'll get 2 times 4, which equals 8. For this one, we'll get 3 times 6, which equals 18. So let's make a ratio out of these two numbers. We'll have 8 over 18. I wonder what happens if we reduce this. This reduces to 4 over 9. Now how does that relate to 2/3 here? Well, look, 4 is just 2 squared and 9 is 3 squared. There we go. Boom, drop the mic. And now for volume. Let's make these rectangles into 3D prisms and find their volumes. So we said this was 2, 4, and I'll say this is 3. We had 3, 6, and I'll say this is 4.5. Alright, now volume, remember it's length times width times height. So we have 2 times 4 times 3 gives us 24. 3 times 6 times 4.5 will give us 81. Let's make a ratio out of these two numbers. We have 24 over 81. When we reduce that, we'll get 8 over 27. I remember back what our scale factor was, 2 over 3. What happens here? Look, 8 is just, what? 2 cubed. 27 is just, what? 3 cubed. Once again, blowing your mind mathematics style. Alright, before I let you go, I'm not going to leave you hanging. I'm going to do a nice example problem for you. So look at this problem. We've got the volumes of two similar figures are given. The surface area of the larger figure is given. Let's find the surface area of the smaller figure. So let's start here with our volume. First thing to do, make a ratio. Our volume ratios would be 384 over 10, 368. If you reduce that, use a calculator, you'll get 1 over 27. Since this is volume, this represents our A cubed over B cubed. Well, remember again, we need to know our scale factor. We need A over B. So how do I get rid of little 3 over here? Cube root on top and bottom. So A over B is going to equal the cube root of 1 over the cube root of 27. And we'll get 1 over 3. Now this is good. This is going to help us get the ratio for our area, our surface area. So remember, our surface area, or area, is a squared over b squared, which we're going to start here, 1 squared over 3 squared, which is going to give us 1 over 9. This we can use to find the surface area of the smaller figure. Set up a proportion, your favorite, middle school math. Yay! 1 over 9, our ratio for the area, equals x, the area of the smaller figure, over the area of the larger figure, 3168. Cross multiply, your favorite. 3168 times 1 is 3168. 9 times x equals 9x. Don't forget that. Now, one-step equation, divide. And this will give us our answer, which will be x equals 352. There. Easy peasy.